Hey everyone, I'm Adam Kelly. First off, just wanted to say thank you so much to all of the new patrons on Patreon. Your support and the support from people buying the courses are what allow us to do things like upgrade the camera that I'm using right now. So I just bought a new camera. The lighting situation in here is still not great. Still going to figure that out, but the camera is a huge upgrade and I'm so happy about that. So thank you. Now, this video is actually in response to a couple of questions that I got, I think, on YouTube. Basically, people were wondering, how do I take the output of an object detector neural network? So, like the mask, basically, that comes out of it that says, these pixels are a person, these pixels are a dog, that sort of thing. And then cut that out so that they can do something with it, paste it onto a picture, or I'm not sure what exactly they're trying to do with it, but doesn't matter. The technique is the same. It's actually surprisingly difficult to do this. So I was working on it. I got it working with Detectron2, and I'm going to show you how to do that. If you're not familiar with it, Detectron2 is Facebook Research's AI library, and they've got a lot of stuff in here. You can actually see a preview. They have a MaskR CNN implementation, which is basically giving you these masks of different objects. And there's some other things in here too, like key points, and I'm not sure what else is in here, but I know there's a lot. So this seems to be the most well-maintained version of MaskR CNN, and so I wanted to use this as a basis for this. So if you go to GitHub and find Detectron2, you'll end up on this page. So if you scroll down to the README section, and then to the Getting Started section, there's a Colab notebook that we can use. If you've never used Google Colab before, it's basically just a free Jupyter notebook in the cloud from Google. There are some limitations, like I think there's a limit to how long you can run things. But the nice thing is you can change your runtime to GPU acceleration. And so you have GPU in the cloud. You don't have to have it on your computer. You can just use it in the browser. So this is just a basic beginner's tutorial for Detectron2, and I'm going to run through it really quick. You can either hit the play button or you can put your cursor in there and do Shift Enter. And it'll ask you if you want this notebook to be running. And so you can just click Run anyway. And then it's going to do some initial setup, and I'll just keep going here. It's going to run a pre-trained Detectron2 model. So basically the point that we're at right here is like after you've trained this on your own data set, or maybe you're using just the defaults for person detection or dog detection or something like that. But the assumption is that you've already gotten to a point where you have a pre-trained network that can detect objects and give you masks. I realize that's maybe a bit of an ask. Someone coming to this might be wondering how to set all that up, but that's for another tutorial, and we have some of those on immersivelimit.com. Not for Detectron2, but for some other things. So up until this point, it's just been basic setup. And now here what it's doing is it's getting this JPEG image from the Coco dataset website, and then it's reading it in with the CV2, the OpenCV Python library, and then it's just showing it. So it's just displaying this image. And the next cell here, if I run this, it's going to load a pre-trained model, and then it's going to run it on this image. So you can see here it's calling predictor on IM, which is just this image that was running. So you'd be able to run this on some other image from the internet if you wanted to, but I'm just using the default for now. And it takes a minute, but now it's set up and we've already got our outputs at this point. So what this cell is doing is it's showing outputs, instances, predict classes. So if I run this, it's going to show the same thing that was already there, but you can see it's the different predictions are showing up in a list here. So there are several different predictions that it's found in this image. And then there are bounding boxes that it's also showing for this. And then if we run this cell, then we end up getting those bounding boxes and those masks here. So the idea here, this is as far as we need to run in this particular notebook, is that we want to take the outline of something, or not just the outline, the shaded in region, and then cut it out of this image and paste it into another image or save it or something like that. What I'm going to do is show you how to cut it out and paste it over top of this same image, just because that's easy, but it should give you all of the code that you need to paste it into another image or to save it off before you do the pasting. So that's what we're going to do now. So we need to insert a new code cell here. So I'm going to click here and then I click plus code. And we are going to start writing some code here. Now we're going to use the pillow library, the PIL. So from PIL, import image. And no, it auto-corrected for me. So now we can do some image stuff in here that we can't do with just plain OpenCV. All right, so we have a lot of code to do here, and I'm going to just explain it as we go, and I think it's going to make sense as it all comes together, but there's a surprising amount of code to get this just to paste one image on top of another. You'd think that there'd be something in the OpenCV library to do it, but I couldn't find it. So let me know if you find it, but this is the best way I found how to do it. So first, we want to get the masks. Okay, and that's actually pretty easy. We say masks equals np.asArray outputs instances, and then pred masks, so the prediction masks, and we have to say .to CPU. And I guess that just pulls it off the GPU. And then we're going to put it in an array into this masks thing. So let's make sure that I think NumPy is already imported here, but let me just double check. Always good to make sure. It would definitely let us know. Yeah, okay, import NumPy as NP. So we're all good there. Okay, so this is going to give us a list of masks in a NumPy array. Then we have to pick one of them. So pick an item to mask, and we're going to say item mask equals masks 1 in this case. Okay, so we're going to use the second element in this array, which actually I believe happens to be this person right here. Hopefully it's the same result as I was doing earlier when I tested it. So now we just have a mask of the single object that we're interested in. Now we want to get the true bounding box of the mask. Okay, and so this is, it's not the same. It's the mask, and it has its own bounding box, but then there's this other bounding box. So it would be nice if we could just use this bounding box as it is, but it seems like they're done in like two separate stages where it detects, hey, we have an object inside of this box, and then it has to do it guesses what the pixels are after that. So that's why I think they're different. So this is a little trick with NumPy that we can do. We're going to call it segmentation. We're going to set it equal to np.where item mask equals true. So what this is doing is it's saying where inside of the item mask is the pixel basically true versus false. And then this is going to return a list of different positions inside of that mask. And well, I can just run it actually, segmentation. We can see what this looks like. So it prints it out, and these are the pixel positions where this is true. So that's what's useful about it. And what we're going to do now is we're going to determine what the bounding box is. So x min, so the minimum x position, equals, we have to convert it to an int, but we get np.min segmentation 1. Okay, so this is actually the second axis because the shape of the segmentation is in like YX order, or like how the height width order rather than width height. A little unintuitive in my opinion, but that's just the way it is. Next, we're gonna try and save a little time by doing x max, and we're going to do np.max. So same idea, we're just looking through this list. What's the minimum x value? Or, well, yeah, it's kind of it's in the second axis, but minimum x value and maximum x value. We're going to do the same thing for y. So I'm going to copy these and we're going to do y min, y max, and then we just have to set these to 0. Okay, and then if we want to see what this looks like, we can just print x min, y min, x max, y max. And now we get these values. So this is basically our bounding box. So it's from 255 to 333. So, somewhere in the image, it's like from here to here. And then we've got 160 to 405. So we get like, I don't know if it's here to here or if it's here to here. Doesn't really matter. But that's our bounding box. All right, so next we are going to create a cropped image from just the portion of the image we want. Okay, so what we want in this case is like just this part of the image. So we will do cropped equals image.fromArray. And we already have an image up above called im. And then we want to basically index into it in this bounding box. So that's pretty straightforward. We just do y min colon y max comma x min x max. So this is pulling out a bounding box using NumPy, and then comma colon so that it gets all three channels, R, G, and B. And then we're going to say mode equals RGB. So it's going to read this in red, green, blue format. Then we want to create a PIL image out of the mask. Okay, so not only do we have this image here, we have a mask, right? So we need to get this into image format, and then we're going to end up cropping it too. So mask equals image.fromArray. And then we're going to actually say item mask times 255 because it is a true false array right now. We want to multiply it by 255. And what this will end up doing, if we say dot as type uint 8, then we're going to end up with a mask that is in 0 to 255 format, which is what we need. And then we're going to crop the mask to match the cropped image. And we're going to do that with cropped mask equals mask.crop. So this is something that's built into that PIL image library. You can just crop things. So that's really convenient. So we're going to say mask.crop, and then we need to crop it from x min, y min, x max, y max. So this is just saying crop it with this bounding box. Now we could have done something similar here. We could have loaded in this image and cropped it, but this was easier to do. Different for this one because we had to convert it first. That's why these are done different ways. Next, we're going to load in a background image and choose a paste option, or paste position. So you might want to load in a different image, but I'm just going to reload in this image because it's easier in this use case, but you can figure out how to do that, I'm sure. We're going to say background equals image.fromArray im mode equals RGB. Okay, so we're actually just loading in this image now into a PIL image. We are going to say paste position equals 300, 150. So we're telling it where we're going to paste this onto the new image. And then we need to create a new foreground image as large as the composite and paste the cropped image on top. All right, so what am I saying here? We're going to create a new image with the foreground, so just this person, and it needs to be on a background that's the same size as this in order for us to paste it. Um, well, we can paste it, but we can't compose two images together. So that's what I'm talking about with the composition. We're going to have to compose two images together. And in order to do that functionality, they need to be the same size. But we can paste something. So we're going to say new FG, so foreground image equals image.new RGB, comma, background dot size. Okay, so we're making a new image that's the same as the background. Then we're going to say new FG image dot paste. And we're going to paste the cropped foreground onto this image in the paste position. So at this point, it would just be like a black image, and we're pasting this new cropped version of the object that we want onto it. Now, in order to do this paste, we need an alpha layer that tells it, like, let's say we have one image that's this guy on a black background somewhere else in this image, and then we also have this original image. We need to have an alpha layer that tells them how to blend together. And so that's what we're going to create now. Create a new alpha mask as large as the composite and paste the cropped mask. So we'll say new alpha mask equals image.new. And then the format is going to be this L format, linear. It's basically just a linear grayscale image. Background.size, comma, color equals 0. That one might not be entirely necessary, but I like to just be explicit with it. And then we'll say new alpha mask dot paste. We're going to paste the cropped mask at the paste position. So it's the same idea here. We're pasting a mask now on top of a black background instead of just the foreground on top of a black background. We're almost done. We're going to compose the foreground and background using the alpha mask. So we'll say composite. So this is a new image that's a composite of the two other images. We'll say image.composite new FG image background, and then new alpha mask. And finally, we're going to display the image. cv2 underscore imshow np.array composite. Okay, so let's just make sure we understand what happened here. We have a composite where we're taking this new foreground image and the original background, and we have to give it an alpha mask that says this is the pixels we want visible from the foreground versus the background. And we're going to show it using this same cv2 imshow helper function that they provide for us. And assuming I typed everything correctly, shift enter, there it is. So I was having fun and I managed to place this person on behind himself on the horse using this composite technique. So you can put him anywhere. Like if I wanted to put him further forward, I might be able to do something like this. Just change the paste position. Now he's in front. So this is a pretty long way to do it, but now you should have all the components you need for pasting or cutting out. Like if you just need the image itself or just the foreground itself, you can probably keep it cropped and then save the alpha layer and then save out the image. So, based on your needs, you can tweak this as necessary. Hopefully it's useful to you as I understood the questions to be asked. And I know that this was tricky, so thanks for bearing with me as I typed all that out. All right, that's it for this tutorial. I know it was kind of long. Honestly, it took me a lot longer to accomplish than I thought it was going to take. It was really quite difficult to get it to work. So I imagine there's tons of stuff like this where you are working on a data set and you get stuck on something. You can't figure out how to manipulate it and get it into the format you need or something like that. let me know what those are, because I can make more tutorials like this and help people out. It'd be super helpful to have that. I also want to say thank you again so much to our patrons and to anyone who supports us financially by buying courses. That honestly is what allows us to keep this channel going. There are costs in running a website, in buying new cameras and microphones and stuff like that, that make the channel a lot better, but they're not free. And so it's really helpful to have that extra, a little bit of extra cash that we can use to just make the channel that much better. So thank you so much, and we'll be making another video soon.